brought to you by Form Systems, the leader in API and cloud gateway technology.
I am Thomas. I'm one of the co-founders behind PredictionIO. Hopefully everyone's still awake after lunch, so you might be getting some sort of tutorial fatigue. But I'm going to try give you a sort of a light-hearted introduction to PredictionIO and how it can be used by going through a tutorial. Being English, I like my pub quizzes and trivia, so I wanted to start with a very quick question for everyone. So, what is it that chess, movies, and automobiles all have in common? And the answer is machine learning. So they've all been reimagined in some way through machine learning. In 1997, IBM's Deep Blue beat the chess grandmaster Garry Kasparov. In 2006, Netflix launched the $1 million prize to improve its own Cinematch algorithm. More recently, in 2012, Google was granted a license for its autonomous driving car from the Nevada DMV. And I think what's exciting about the time that we're living in, there's plenty more to be reimagined. And now, here in 2014, we're at the inaugural Predictive API conference, and hopefully we're going to see lots more interesting applications of machine learning. Sorry, my notes and my slides are not connected. So what is PredictionIO? So we call it an open source machine learning server. We're very much focused on helping developers add predictive features into any web and mobile application through a simple API. For instance, this could be something like product recommendations in the way Amazon does, or news recommendations in the way Flipboard does. We're focused on offering an open source tool that's built for developers and that's adaptive enough to unique prediction requirements. So by predictive features, I think by now this audience sort of knows what we're talking about, but some classical examples of this, things like Amazon's people who bought this also bought this, Gmail, obviously, spam detection, Facebook's newsfeed, you might not think of it this way, but can be seen as a recommendation problem of what different items you show in someone's newsfeed. And I guess the term has also been popularized as something data products, which was popularized by, I guess, DJ Patil and the team at LinkedIn. So things like people you may know. I guess much more complex predictive apps are things like digital assistants. So most of us nowadays on our smartphones will have one of Google Now, Apple Siri, or Microsoft's Cortana. I think if you're interested in digital assistants in general, there's a cool startup called Wit AI, which you should definitely check out, and helps you it gives you a developer tool to input speech recognition and hopefully build your own digital assistant. But I think PredictionIO, we share the sentiment of one of the previous speakers that it shouldn't just be these companies, it shouldn't just be the Googles, Microsofts, and Apples of the world who are making use of machine learning and building predictive apps. So the first important thing about PredictionIO is that it's open source, 100%. It's under active development. We're very fortunate to be supported by a program called Mozilla Web Forward, and more recently by Stanford's StartX program. In terms of community contributions, we've had some great contributions around SDKs and plugins, so things like Node and Magento. Obviously, a lot of documentation, tutorials, and now what we're really able to see with our latest release is the ability to contribute actual engines and evaluation metrics on top of PredictionIO's infrastructure. So, just a few weeks ago, we released the latest version, the 0.8 series of PredictionIO that was codenamed Imagine. And the main difference from previous releases, we now are built on top of Apache Spark, which hopefully most of you are familiar with. It gives us a very sort of scalable, fast data processing framework to be built upon, and it's an extremely active community. We also have this concept that I'll go into of, we call it the DASE architectural pattern. It stands for Data, Algorithm, Serving, and Evaluation. And what that allows is a lot more flexibility about being able to build custom engines for your specific application. The other thing that we announced is that we've moved away from the AGPL license, and we're now 100% Apache 2. So, without further ado, I don't think anyone will recognize that cityscape, but it's Phoenix, Arizona, otherwise known as the Valley of the Sun. And we're going to go into a quick tutorial. The reason why is because we're going to be using Yelp data from the Rexis 2013 challenge. It's also hosted up on Kaggle, and it's essentially a Yelp user businesses and reviews data set from the city of Phoenix, Arizona. If you want to check out either of the tutorials that I'm going through in a second, I've created these bit.ly links, so PIO Quick Start and PIO Yelp will find you the right location in our docs to follow along. But the data set essentially consists of over 10,000 businesses, over 40,000 users, and about 300,000 reviews. And the goal is essentially to be able to predict the top restaurants for each user. So I'm also going to introduce you to this little friend of mine called Dorami, but we'll get on to that later. So this is... Can everyone see that okay? Just about. So on the left side, we've got the tutorial that I'll be following along. So this is the quick start tutorial for PredictionIO. So we have two main templates. One at the moment for recommendation based on MLlib's ALS algorithm, and one for classification based on MLlib's naive Bayes. And I'm going to take you through the steps of this quick start. So I'm just going to get a Vagrant. Drop the pen would help. God, it's hard to code with a font this big. See anything? Just give that a second. Maybe if I do this. Sorry. Okay, so I'm just going to make that a bit smaller so I can actually see what's going on. Right, so all I did there is I've launched PredictionIO using Vagrant, so hopefully you're familiar with Vagrant runs on top of VirtualBox. And then what we're going to do is going to SSH into Vagrant. And the quick start, essentially what it takes you through to start off with. First, we're going to add PIO to our path. And then, essentially, all you do is you copy from our template directory the recommendation template, and we've put that in a directory called my engine. And then I've already, to save us the hassle of having to wait for the internet to download the dataset, we've got a small example dataset from MovieLens, which is just a set of users, items, and ratings. That's that sample MovieLens dataset. And then what we're going to do is run through the main commands in PredictionIO. So the first command is to build an engine. So you just need to give this a second. And that takes the different components, the data source, the data preparator, the algorithm, the serving, and the evaluation component, and it builds an engine. This is now your engine's ready to train. And we run PIO train. And this will take a little second because this is invoking Spark, and at the moment, obviously, this is running on a Vagrant instance on my MacBook, which isn't a very realistic production environment. But what this will do is it will go through the training, and what we're doing here is we're training that ALS collaborative filtering model based on just this very, very basic sample movie lens data set. Okay, and now that's complete. What we can do is deploy the engine. I'm going to put it globally. Okay, and we get the message saying that it's ready to serve, so we should also be able to see on port 8000. So now we've got a live deployed engine. It gives us some very basic information about when the training started and ended, about the model that we've trained, and about the parameters that we obviously just use the default parameters at the moment. And then what we can do is we can make a request to that engine, and what I've done there is I've sent it user ID 1, and we've asked for number 4 top recommendations, and it's come back with the top 4 products and the scores for each of those engines. Obviously, this is just a quick start, so the data set isn't particularly interesting, and neither is the output. So what we're going to do now is, if we stop that engine, what we want to do is we want to take that template and we want to apply it to our Yelp data set. And then what we want to do is we need to customize the data source, and we need to customize the serving layer so that rather than just get back some sort of restaurant ID and some sort of score, we get some more useful response. So let me go into... So, okay, and what we're going to do is we're going to do the same commands but for this new engine, and then I'll show you the code that I had to modify from the template. So we're going to run through essentially what we've got here. We've got an engine that I've started from the template, and then I've written the code to change the data source to use the Yelp dataset rather than the movie lens. And I've altered the serving component so that we can return the restaurant name and the score rather than just an ID. So sorry, we just have to run through the training again, given that we're using a new data set. And while we're waiting for this, might as well go ahead and show you. So for the other tutorial, so there's the quick start, and then there's the building a simple Rails app using PredictionIO. So still using the item recommendation engine, this tutorial will take you through building a very simple Rails app on a Postgres database. And this is essentially what you'd build if you go through the tutorial. So it gives you a very simple front end. So you've got most popular users and the number of reviews. It happens to be a user called Thomas, so if we can check out if the internet's working. If I have a connection, maybe we'll come back to that. So in the meantime, our engine's finished training. So again, we're going to deploy. Okay, and this is loaded while we wait. So the problem we have here is that we're not just getting restaurants returned, we seem to be getting all kinds of other businesses. So this user, Thomas, who obviously lives in Phoenix, seems to like pizza trucks and doesn't seem to like Clarendon Park apartments. And what we've got over on this side is what's generated by PredictionIO. So this app is querying the engine, asking it for the top 5 recommendations, and it's come back with these businesses over here. And because we're getting the top recommendations, they've all got a predicted score of 5. But we don't really want to show things like Andy's Nails and Atomic Comics, so what we're going to do is, with this engine, if I come back here, so what I need to show you is the code in the serving that's been modified. So if I just load this. So this serving.scala file. Okay. So essentially, we've added in some filtering logic here, which goes through and it takes out businesses that only belong to the restaurant and food category, and it also translates the business ID into the business name. So then, when we've queried that engine, we're now getting back these different businesses, so Mojo Bowl, Jimmy's $5 Pizza, and Pop Soda Shop. So what we've been able to do there is take the template, not just use it on a new data set, but we've been able to essentially add sort of business logic, add logic to the serving layer so that we can decide how the response is returned from the PredictionIO engine. Then what I'm going to try and do, which requires the internet to work, but let's see how it goes. Is rather than just show you the Ruby front end filtered for restaurants, which doesn't seem particularly impressive. What we've done, if I can find the right window, here is, it's way too large. Hopefully everyone can see that still. Is we have written some code for something called Dorami, which some of you may be familiar with. GitHub released a project called Hubot, which essentially allows you to write your own internal chatbot. So if I open up Yelp, it's again not very easy to see. But essentially what we've got here is we've got a script for our bot that's called Dorami, where I can essentially, in our company chat room, we use something called Hipchat, which is a product by Atlassian. I can essentially say that I'm hungry, and what it's going and doing is doing a post, doing basically an HTTP request to the PredictionIO engine, taking the query, passing the JSON, and then hopefully responding. So did this over the weekend, so let's see if it actually works. So we've got room PAPIs. There's a bunch of inbuilt scripts that do fairly mundane things. So I can say to Durami, let's see, that's an odd one. So I can ask Durami to give me an image for PAPIs. That's a bit better. I can say Durami, ship it, and it gives you silly motivational ship it pictures. And then hopefully what the script I wrote, if we tell Durami that I'm hungry, it's now pulling back the request from PredictionIO, so you can see you've got the same output that we had when I was querying the server directly. And it's pulled in the recommendations and passed the JSON and showed it in our chat room. So this is nice. So we've now basically customized the engine. We're using the Yelp data rather than the movie lens data. We've modified the serving to show us the restaurant name. We've also filtered out anything that's not a restaurant. But this still isn't hugely useful because you've got to be thinking, actually, if we're talking about restaurant recommendation, you probably care about where you are right now, so we care about the location. And you probably don't want it to just tell you any old restaurant. You probably want to be able to say, I want to know the best place to get tapas nearby, or I want to go get a beer after the conference. So hopefully, if I could type for tapas near Barcelona. Let's see if that works. Yes, so hopefully you'll be able to actually build something like this, and it'll actually give you the Yelp recommendation. I have to admit, I have slightly cheated there because the data set that I got from Kaggle was obviously only relevant for the city of Phoenix in Arizona. So here what I'm doing is I'm querying the Yelp API to do the sort of location lookup. But in theory, you can, if you had the data that would allow you to do it, in the same way that we modified the serving layer to just show restaurants and to show the restaurant name, you could also do the same to query against a particular geolocation or for a particular category of restaurant. So one more thing, maybe I should do it in the everyone. I think everyone in Palo Alto is probably awake. No, maybe not. Like 8 a.m. So let's do this. So hungry for beer. Yeah. Campus. What's it called? Campus Nord. Barcelona. Frankfurt, apparently. I don't know if that's a good recommendation or not. But at least now everyone in the company will know what I'm doing. So anyway, that comes to the end of my playing around with chatbots and going through the PredictionIO demo. So let me get back to slides over here. So I think hopefully what I started to get across through that very quick demo was that I think one size fits all works very well for SOCs. It doesn't work very well for predictive applications and predictive features. I think that means it doesn't mean that every company needs to build everything from scratch in-house. I don't think any of the companies presenting today believe that. But what they do need to do is be able to select the right algorithms, select the right features, be able to evaluate performance for their specific application. And then obviously different companies have very different specific business logic. So recommendation for movies is not the same as it is for restaurants. It's not the same as it is for music or news. Each of the applications is unique. So for restaurants, as we saw, you care about location, you care about category. For news, maybe you care about freshness. For e-commerce, maybe you care about inventory. So what I was talking about earlier, this DASE pattern that we have, an engine essentially represents a type of machine learning task. So recommendations one, classification might be another, clustering might be another. And our goal of this is to really be able to streamline the data engineering process and offer this sort of modularized code base that can be customized to each requirement of a different use case. So what we have here is the main components being the data source and preparator, the algorithm, the serving and the evaluation layer, which I didn't go into in the demo, but obviously for recommendation, you'd be using metrics like mean average precision or area under the curve. The main benefits that we have over, obviously you could go pick up Spark's MLlib library and build what I showed you from scratch using the library itself. But we make it a lot easier to deploy a Spark MLlib model as a service, which you can then use in a production environment. We obviously support JSON queries, both to import data and to retrieve predictions. And we have this nice sort of separation of concern by the way that we separate out the different components with the DASE architecture. We also support model updates, so as new data comes in, you can retrain the model and redeploy it without having any impact on the deployed model. So this is a very simplified schematic of our architecture, and the reason it's in Lego is mainly because I have a 3-year-old son who seems to constantly be playing with Lego, but also I think it hopefully gets across the idea that we're trying to have the sort of the building blocks for building predictive applications. So, as I said before, we're built on top of other open source frameworks. So we use Apache Spark as our core data processing framework. We use HBase for storage. And we use Elasticsearch for saving all the metadata. So when an engine is built, when an engine is trained, when it's deployed, that's all stored in Elasticsearch. And we also, for a particular engine instance, so that's when an engine is trained with a certain set of parameters, with a certain data set, we store that, we serialize that as JSON, and we store that in Elasticsearch. As you can see, we've got SDKs for Ruby, Python, Java, PHP. So I guess there's two core use cases. One is if someone just wants to use an engine, they're able to interact with the engine to query it for a prediction using any of those languages. We also have community wrappers, wrappers that have been contributed by the community for .NET, for Node, and then also what I didn't show in the demo as well, because we're just using a static data set, we have something called the event server, which allows you to essentially capture all the data that's happening in your application. So let's say in the context of Yelp, if a new user account is created, or if a new business is created, or if a user rates or leaves a review for a business, we use an event-based style to capture and import all that data, and we store that all in HBase ready for when it's read in and trained. So the main PO commands, which you would have seen I would have repeated, are essentially to build, which takes the different components, creates the engine, train, and also deploy. And I mentioned at the start of the tutorial that we have these concepts of an engine template. So you can think of that as the basic skeleton of an engine. So For recommendation and for classification, we have these templates in our quick start tutorial. And then what we have is different users and companies that are using PredictionIO have essentially customized that engine for their use case. So whether it's item recommendation for something like product recommendation, similarity, something like similar movies, user recommendation, which is like the people you may know kind of feature. And then in classification, we have people working on things like churn and sentiment analysis. And here's this, I think I've just gone through it, but here's a snapshot of some of the different things that we have people. So these aren't companies, these are more open source contributors who are building engines. And what's nice is that they're sharing those engines. So as well as starting from the engine template, you could also start from an engine that someone has already built and then customize that if it closely fits the needs of your own predictive app. So we've got people working on doing trend detection, using sort of Yahoo Finance data, sentiment analysis, churn prediction, user recommendation. And I think the third thing that I'd mention about PredictionIO is that it's very much a tool that's built for developers. I think we're trying to make it possible for developers who don't have sort of deep machine learning backgrounds, sort of research backgrounds, to be able to at least be able to take an engine, to be able to import the relevant data and be able to query the engine for a prediction and have that something that's useful for their own application and usable in a production setting. One of the things we get asked a lot is, do you have a pure sort of cloud version of PredictionIO? So obviously there's services like Google Prediction API, Microsoft's new Azure, and IBM's Watson. So I think in our experience we have lots of people ask us about this, but we also have lots of companies that are less than keen to import all their user data into the cloud. Lots of companies even have regulation and rules about where they can keep their user data, and often it has to be kept in national borders. So joking aside, in terms of PredictionIO, we support, obviously, can be installed from the source or from binaries for Linux, but we have support for both Docker and Vagrant, which I showed you. And then the other nice thing is we're on Amazon's marketplace, so sort of one-click installation, PredictionIO can be launched on Amazon. So this is a snapshot of some of the companies that we're either working with or have been using PredictionIO to power some of their applications. It's a real spectrum. So on one end, we have some of the largest media companies in Asia and Latin America. And at the other end, we have some very small but fast-growing startups in domains as diverse as sort of fashion and food and even health. I created another bit.ly link for this PIO Resolve. There's a nice blog post up by a company which, without any support from us, actually went ahead and used PredictionIO to build a recommendation engine for this company, United Sellers, who apparently use the spree commerce platform, which is not too dissimilar from something like Magento. And the nice thing about this is they've seen sort of very good business results. So just by introducing a recommendation feature onto their site, they ran an A/B test and had very strong sort of uplift in their revenue. So I think if you forget everything else and all the silly stuff with chatbots that I've talked about today, I think the three things, the sort of three takeaways that I'd like people to remember is obviously PredictionIO's 100% open source and Apache 2 license. We're adaptive, and we believe that we hope to build a tool that supports the sort of unique prediction requirements of different developers and different businesses. And we're very much a tool that's built for developers. We started off as a very small team, so 3 of us, 2 of us are doing our PhDs at UCL in London. Another guy was working at the time at NVIDIA over in Silicon Valley. It's about sort of 2.5 years ago. And I think now we've got to a point where we've been fortunate enough to get funding and grow the team to about 3 times that. We've got sort of tens of contributors working at big companies like Disney and Expedia and helping contribute not just sort of wrappers and docs, but also now finally being able to build engines that run on PredictionIO. We've got a few hundred live servers deployed by various companies, and we have sort of very large community of developers who are sort of following the progress of PredictionIO. So we're just getting started. We're hiring both over here in Europe, in London, and also Palo Alto, where our main office is based. And there's some basic links. And I'm going to be around for the rest of PAPIs, so if anyone has any questions. We do offer sort of an enterprise support license and enterprise support services for anyone who's interested in that. Yeah.
Thank you, Thomas.
Brought to you by Form Systems, the leader in API and cloud gateway technology.